In this video, we are going to talk about integration. Let's say we have a function y is equal to f of x, where y depends upon x. When we say that integrate the function y with respect to x, this is how we write it. So this variable is the one on which this y depends. So y depends upon x. We write integrate y with respect to x, or we can also write it as integrate f of x with respect to x. Now if we have a function f of x and we integrate it with respect to x, this is how we write it. But whatever we get after integrating a function and we calculate its derivative, we should get back the function. This is like saying that derivative and integration cancel each other and we get back the function. I'll give you an example. Let's say we have a function y equal to x square. We are integrating x square with respect to x. Suppose that by power rule of integration we got the answer x cubed by 3. We will see later on how did we get this answer after integrating x square with respect to x. So we have integrated a function x square. Now we are going to calculate the derivative of this integrated function. Remember we said that derivative and integration cancel each other out. First we calculated the integration of x square, and now whatever the answer we got, we are calculating its derivative. So 1/3 as it is, and the derivative of x cubed by power rule of derivative is 3x square. 3 cancels with 3 and you got back your function x square. So in this sense, know that derivative and integration will cancel each other out. So what you do is, if you find the integration of some function and let's say you got some answer here. So what you do is, when you calculate the derivative of this answer and you get back your function, this function, you should know that you have calculated the right integration. Let's start with some rules of integration. Let's say we have to integrate the function 1, which is a constant function, with respect to the variable x, which could also be written as integration sign dx. If there is nothing written here, an integral sign, and dx is here, then its answer would simply be the variable x. Now we know that if we take the derivative of this x, it should be the same thing which is written here, and here you have 1. If nothing is written, so it means there is 1. So you calculate the derivative of x with respect to x, which is 1, and 1 is written here. So you know that this integration of 1 with respect to x that we have calculated, which is equal to x, is correct. So we have the formula dx is equal to just x. The same way, if we have, let's say, dz, it would be integration of dz, it would be z. If we have integration of du, it would be u. That's the first formula. Now let's look at the integration of the function x with respect to x. Just like the power rule of derivative, there is the power rule of integration. Here the power on x is 1. So power rule of integration says add 1 into the power. So there is already the power 1, then you add 1 into the power divided by this whole power, which is 2, which becomes x squared by 2. Now we know that if we take the derivative of this expression, it should be the same thing which is here. Let's calculate the derivative here. 1 over 2 is on the side, and x square derivative is 2x. 2 cancel with this 2 and you have x. This x is same here, which is written here. So we know that integration of x dx is x square by 2, which is power rule of integration. Now let's look at the integration of x square by power rule of integration. So it says x, add 1 into the power, and this whole power also written in denominator, which gives us x cube by 3. You can check that the derivative of x cube by 3 is x square, which is written here. Now let's find the integration of x cube with respect to x. So by power rule of integration, it would be x to power 4 by adding 1 into the power 3 divided by the same power here. Let's say you have 2 into x to power 4 dx. Remember that you can always take the constant out of integral sign. So we take the constant out of the integral sign, and we have to find the integration of x to power 4 with respect to x, which could be written as 2, and then the power rule of integration, which is x to power 5 divided by 5, some constant. Just remember that in all above formulas we will keep on adding the constants, and if we take the derivative of this expression, we should be getting back this 2 into x to power 4. Let's calculate the derivative here. 2 as it is, 1 over 5 as it is, x to power 5 derivative is 5x4 plus c is the constant, its derivative is 0. So 5 cancels with this 5 and you get back 2 into x4, which is the same thing as in here. So we have 2 into x power 4 dx derivative is 2x to power 5 by 5 plus some constant. Let's find the integration of 1 over x dx. We will write it as ln x plus some constant. Let's take the derivative of this expression, which should be this. Is it so? Ln x derivative is 1 over x plus derivative of c, which is constant, is 0. So we get back 1 over x. So it means that this formula is correct. That is, integral of 1 over x dx is ln x plus some constant. Integration of e power x dx is the same, e power x plus some constant. Remember that e power x is that kind of function such that its derivative is the same and its integration is also the same. Let's find the integration of 1 over 1 plus x squared dx, which is tan inverse x. Why is it so? Because the derivative of tan inverse x is 1 over 1 plus x square. Integration of 1 over square root 1 minus x square dx is sine inverse x, because derivative of sine inverse x is 1 over square root 1 minus x square. Integration of x square root x square minus 1 dx will be secant inverse x, because the derivative of secant inverse x is 1 over x into square root x square minus 1 plus some constant. Integration of cos x dx will be sin x, because the derivative of sin x is cos x. Integration of sin x dx will be minus cos x, because when you take the derivative of minus cos x, minus as it is, cos x derivative is minus sin x, which becomes sin x, which should have been here. So we have integration of sin x dx is equal to minus cos x plus some constant. Now know that if you have f of x plus g of x, that you have to integrate with respect to x, then you can always write it as integral sign f of x with respect to x plus integral sign g of x with respect to x. So you can separately write these functions. And if you have a constant being multiplied with a function and then you have to integrate that function with respect to x, then what you can do is you can take the constant out of the integral sign and then integrate f of x with respect to x. So in the next video we will be using these formulas to find the integration of several functions.